You should already have an idea of what a break-even point is from other classes. This is when total sales equals total costs. The amount of money we are making is the same amount of money we are spending. There is no profit or loss. I always ask this question in class. Is breaking even a good thing or a bad thing? What do you think? It really could be either or. It depends on the circumstances. If this was your first year in business, where most companies will lose money, then this would be considered a good thing. Or even if we've had losses for several years and now we're breaking even, this would also be a good thing. But let's say you've had a steady profit over the last few years and now you're breaking even, then this would be a bad thing. It's really all relative to what's going on in the business. There are two formulas that pertain to the break-even point. The first formula is to calculate the break-even point in units. This will tell us how many units we need to sell to break even. The formula is fixed cost divided by the contribution margin per unit. The second formula is the break-even point in dollars, which means sales dollars. This will tell us what our sales amount needs to be in order to break even. The formula for this is fixed costs divided by the contribution margin ratio. Let's practice these formulas now. This is still problem 3 on your classwork, part C though. It's still the same information we had before. We need to calculate the break-even point in units. You should pause right now to try to calculate parts C and D, and then unpause it to see if you got it right. Remember, this formula is fixed costs divided by contribution margin per unit. What is the amount of fixed costs? Fixed cost is $340,000. We will divide this by the contribution margin per unit, and we know this number from part A, which is $68. Divide 340,000 by 68. This will equal 5,000 units. We need to sell 5,000 units in order to break even. Any units we sell over 5,000 would be a profit for us. Part D is to calculate the break-even point in dollars. Remember, this formula is fixed costs divided by contribution margin ratio. We already know that fixed cost is $340,000, and we know the contribution margin ratio from part B, which is 34%. We're going to divide 340,000 by 34%, and this will equal $1 million. This tells us that we need to either sell 5,000 units or make $1 million in sales to break even. Please note that it's the same thing. If we sell 5,000 units, we would then also be making $1 million in sales. Our next analysis topic is the margin of safety. The margin of safety is the difference between your expected sales and your break-even point in sales. Think of this as your safety net. You want to be as far away from the break-even point as possible because that means you're making more of a profit. Calculating margin of safety is very easy. It is your sales minus your break-even point in the sales dollars. You can also turn this into a percent, which can be a more meaningful calculation usually. The margin of safety ratio is our margin of safety, which is the expected sales minus the break-even point. So this numerator could just be your margin of safety, divided by your expected sales. Once again, a higher number is better. Let's practice these formulas. Once again, you should pause this video and try to do these practice problems yourself. We're still working on problem number 3. We're on part E now. Same information, we want to calculate the margin of safety in dollars. As a reminder, this formula is sales minus your break-even point in the sales dollars. We need to calculate our expected sales first. To do this, we multiply the number of units we plan on selling by the amount we sell it for. We expect to sell 8,000 units at a cost of $200 per unit. This would be 1.6 million. We calculated our break-even point in sales dollars in Part D, which is $1 million. The calculation for this would be the $1,600,000 minus the $1 million, which would equal $600,000. This is how far away we are from our break-even point, $600,000. Part F is the margin of safety ratio. Remember, this formula would be our margin of safety we calculated in Part E divided by our expected sales. To do this, it would be $600,000, our margin of safety, divided by the 1.6 million, which was our expected sales. Remember, we're going to need to put this into a percent because it's a ratio. It would be 37.5%. Our last analysis is going to be the target net income. This is similar to the break-even point, whereas our target net income was $0 when calculating the break-even point, and here we will want to find a specific profit amount. The formulas are extremely similar. We will be able to calculate how many units we need to sell or what our sales dollars needs to be in order to achieve that specific net income. For example, I want to make $1 million this year in net income. What do my sales need to be to achieve that? Or how many units do I need to sell to achieve that? The first formula is to determine how many sales in units we need to sell in order to achieve our specific net income. We would add our fixed costs plus that target net income. In my example, it would be $1 million, divided by your contribution margin per unit. The second formula is to see what our sales in dollars needs to be in order to achieve that target net income. We would add fixed costs plus the target net income, then divide by the contribution margin ratio. Let's practice this problem now. This is part G. We want to find the required sales in units with the same information we've been working with. The formula to calculate required sales in units is fixed costs plus target net income divided by contribution margin per unit. What are our fixed costs? $340,000 plus our target net income, which is $170,000. This is our numerator. Our denominator is our contribution margin per unit, which we calculated in part A. It was $68. $340,000 plus $170,000 is $510,000. Divided by 68 gives us 7,500 units. This means that we need to sell 7,500 units in order to earn $170,000 as our net income. Part H wants us to calculate the required sales in dollars to achieve a target net income of $170,000. The numerator is the exact same as Part G. It's the fixed costs plus the target net income. The denominator is what is different. It is our contribution margin ratio. We calculated this in Part B. It was 34%. So 510,000 divided by 34% equals $1.5 million. We need our sales to be $1.5 million in order to achieve a net income of $170,000. These formulas are all pretty simple to do, but as you can see, they do build on one another. This means that if you incorrectly calculate, let's say, the contribution margin at the beginning, then it's like an avalanche and all of your other formulas will also be calculated incorrectly. These last few slides, we're going to bring all this information together. This is the CVP graph, and remember CVP stands for cost, volume, profit. This is just a visual of all the formulas you just calculated. Take a moment to look at this. At the bottom, we have the sales. On the side, we have dollars. Here's our fixed costs. Then we have our variable costs, right? When you add them together, we get our total cost. This yellowish line right here, this is the sales line. The more units we sell, the more money we make. Where our sales and total cost meet, this is our break-even point. You can go across and look at the break-even point would be in dollars and what the break-even point would be in sales. Anything above that is our profit area, and we can also calculate our target net income from here. Anything below the break-even point would be a loss. Our last topic is taking a look at the income statement for a company that likes to do a CVP income statement, cost, volume, profit. Your net income would be the same regardless on what type of income statement you're using. We are just formatting it a little differently. What we're going to start with is showing the contribution margin. We take our sales minus the variable costs to equal our contribution margin. Then we will subtract all the rest of our costs, the fixed costs, to get our net income. This is what it looks like. Let's do a practice problem now. This is our last one. It's still problem number 3. It's the same information we've been using. It's part I. We want to create a contribution margin income statement. First, we need to put our total sales figure in, which we have already calculated it before. It was the amount of units we're selling for the amount we're selling it for. 8,000 units times $200 per unit, our total sales would be 1.6 million. Next, we have to calculate our total variable costs. We're selling 8,000 units, and the variable cost is $132 per unit. When we multiply 8,000 units by $132, we get 1,056,000. The contribution margin would be these two numbers subtracted from each other, which is $544,000. Then we have to put in our fixed costs, which is $340,000. Our net income would be our contribution margin minus our fixed costs. This would give us $204,000 as our net income. And that's it for this chapter. Thank you, everyone. I hope you learned something. Please let me know if there's any questions that you have, and don't forget to submit the classwork. Have a great week.